Good morning class, good morning everyone. In this video, I'm going to share with you binary addition. So this is how actually computer works when it adds a number. Okay, binary addition is simple to learn since there are only two characters, 0 and 1. So 0 means off in a specific circuitry and 1 means on in a specific circuitry. So to consider, it is performed in the same manner as decimal addition, meaning the numbers we are actually using are decimal number. So decimal number, DC means to the base 10. Okay, there are only 4 possible combinations when adding these two numbers. This is shown by the following table for binary additions. Okay, so 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. And 1 plus 0 is equal to 1. 1 plus 1 is equal to 0 plus a carryover of 1. Okay, these are actually the rules in binary addition. Okay, to add two numbers, you can either count two digits in sequence or you can simply remember the results of adding the 4 possible combinations of digits. As given in the addition table, carryovers are performed in the same manner as in decimal arithmetic. Since 1 is the largest digit in binary system, any sum greater than 1 requires a digit be carried over. Similarly, the addition of binary fraction is carried out in exactly the same manner as the binary addition of integers, and when more than two binary numbers are added. Okay, the numbers are accumulated to a running total 1 at a time. So we do not use the same exorbitant amount of carrying over. Okay, so these are the following examples of binary addition. Okay, so let us add this one following the rules of binary addition. Okay, so 0 plus 1 is equal to 1 by following the rules. 0 plus 1 is equal to 1. Yes. Then 1 plus nothing is equal to 1 or bring down 1. Okay, to check the conversion from binary to decimal is this one. So the value of this is, look at the table here. So 0, 0 here means 0, 0, and 1 is equal to 4 since 0, 2 is off, 1 is off, and 4 is on. So count only the on digit. So this is 4. Next, 1 on here, on the 1, and then next digit is on, means 2 and plus 1 is equal to 3. So count only the on digit. So 4 plus 3 is equal to 7. So this is correct. Next, example number 2. Okay, so 1 plus 0 is equal to 1. 1 plus 0 is equal to 1. 0 plus 1, it's the reverse actually, it's also equal to 1. This time, 1 plus 1 is equal to 0 plus a carryover of 1. 0 plus a carryover of 1. Since there are no digit next to this, so you bring down the 1. So actually, you put in mind, if 1 plus 1 actually, it's 2. So you think of 2 in decimal in decimal to the base 10 is just equal to 01 or 10 in binary, since the first digit is off, so do not count, and the second digit is on, and 2, so you count. So meaning 01 is equal to 2. That's why you bring down this 0 here and you carry over this 1. Okay, so next, number 3. So it's actually decimal numbers, adding decimal. It's all the same, you just write the decimal in column in binary. So 1 plus 1, so again 1 plus 1, 1 plus 1 is actually, you put in mind that 1 plus 1 is 2 in decimal, so that's 2 in decimal. So the equivalent of that in binary is 0, 1, meaning of the 1, on, and 2. So meaning that's 2 in binary, or subscript 2. Okay, so you bring down the 0 there, you write the 0 here, and you carry over this 1 to the next digit here. Okay, so next 1 plus 0 is 1, plus 1, it's, you put in mind that's 2, so the same. So you write 0 here, again you carry over the 1 to the next place value. Okay, so next, this time you cannot find this one in the rules. So 1 plus 1 plus 1 is actually 3 in decimal. So in 3 in decimal is in decimal to the subscript 10, that's equal to 1, 1 in binary subscript. So that's 3 because 1 is on and this 2 is on. So that's why 2 plus 1 is 3. So this is 3. So you bring down this 1. There, you put here the 1. And this 1, you carry over to the next place value here. 1. Okay? So this time, 1 plus 1 is 2 actually in decimal. So this is 0, 1. Plus 0, it's 2. So 2 in decimal is 0, 1 in binary. So again, you bring down the 0, you carry over the 1. Okay, so next, 1 plus 1, it's actually 2 here in decimal, and that's 0, 1 in binary. So the same, you write the 0 there, and then you carry over the 1 since there is no digit to the left, so you bring down. And then you copy the decimal point here. Okay, so we will explain further this decimal, how to arrive this decimal here on the next topic. Next, number 4, example. Okay, so binary addition, 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. Again, 1 plus 1 is 2. Put in mind that 2, again, in decimal, the numbers we actually use, and that's 0, 1 in binary to the base 2, because off, 1 is off and 2 is on. That's why the value of this is 2. So you bring down the 0 there, here, 0, and then you carry over the 1. here to the next place value here. Okay, so next 1 plus 1 plus 1 is actually 3. That's 3 in decimal is equal, that's equal to 1 1 in binary, mean 1 is on and 2 is on. So 2 plus 1 is 3. So you bring down here the 1 and then carry over to the next place value this 1. Next, 1 plus 0 is equal to 1 plus 1, that's equal to 2. 2 in decimal is equivalent to 0 1 in binary. So again, that's 0 carry over 1. Okay, so next 1 plus 1 plus 1, that's 3. So 3 in binary is here 1 1. Okay, to check if this is correct, okay, so let us check. 1 here is on, so you count the 1. Next, 2 is on, here is off, so do not count the 4 of this one. So I'll write it down. Next digit is 1, here 1. Next, you count the 8, then off 16 is off, then 32 is on, here 64 is on, so you count 62, 64, count all the on digit, 64 plus 32 here plus 8 plus this one 2 and 1 3, so 64 plus 32 plus 8 plus 3. Okay, so you add, get the sum. So this is 10 17. Okay, this is 17 carry 1, oh that's 10. Okay, that's 107. So 107 is equal to here 107. So meaning the equivalent of this one is 46 and this one is 61. So you just convert it to decimal by looking at the table here below. Okay, so next, number 5 example. So this time we can actually add this one directly. So to convert, this is 7 here because this is 1 plus here plus 2, next digit is 4. So because 1 times 2, 2 times 2, 4 times 2, 8 times 2 times 2, meaning numbers which are powers of 2. Okay, so okay, let us add this one directly. We can actually add the same as in decimal numbers by adding just the 2, then the sum will be added next, then the sum will be added to the next number. Okay, but we can actually directly add this one. So this is how to add directly. So just simply think, what's 1 plus 1 plus 0 plus 1 plus 0. So there are actually 3. So 3 in decimal, that's equal to 1 1 in binary, meaning 1 is on and 2 is on. So that's why it's 3. 2 plus 1. So you bring down here the 1 and you carry over the next place value, the 1. Okay, this time you add 1 plus 1 plus 0. So there are actually 3. So 3 the same, 1 carry 1. Carry over 1. Next, this one, 1 plus 1, 2, 3, 4, 5, 6. So how are you going to write this one with the binary? So 6 in decimal, actually, in decimal or in binary is equal to which digit to on. So dapat on and 4 and 2. So off first the 1 here. Next, you turn on the 2 and you turn on the 4. So this is 0, 1, 1 is the value of 6. So you write here 0, 1, 1. So to check if this is 27, so this is the first digit is this one is 1. Okay, that's 1 plus 2. 4 is off, 8 is on, and 16 is on. And 16 is on. This one is 16. Here, 16. Okay, so the fifth digit here. This one, okay. Let us write this on here. 1, 1, 0, 1, 1. Okay, so you add the on digit. Okay, this one is 24 plus 3. Okay, and that's 27. Okay, so meaning the answer is correct. Okay, so next, again, a computer cannot add only small numbers. It could actually add large numbers. So meaning we can actually add several binary digit to add. So, okay, so again, let us add this one. 1 plus 1 plus 0 is 2. So 3 plus 0, so meaning 3. 3 in decimal again is equal to 1, 1 in binary. 1, 1 on the 1 and on the 2. So meaning bring down the 1 here, carry over the 1 here. Okay, next, 1 plus 1 is 2. So plus 1 here at the bottom, it's 3. So the same, 1 carry over 1 here. Okay, so next, 1 plus 1, 2, 3, 4, 5, 6. Okay, 6 in that's decimal. The equivalent in binary is again 0, 1, 1, meaning turn on the 2 and turn on the 4. Turn off the 1 here, off, so do not count. So that's 0, 1, 1 is 6. So you bring down the 0 here, only the 0, and you carry over this to 1. This one above here. So 1, 1. Okay, so this time you count this one as 3 because 1, 1 is 3 in decimal. So you count this one as 3. Start with the 3, 4, 5, 6, 7, 8. So that's 8. 8 is here. So meaning you turn on this one and off all this here because it's 8. So meaning the answer is 3, 0, 1, 2, 3, and 1. Okay, so to check if this is 67, okay, we write it again here. Let us check. I just overwrite here 1. You write here 1, 4, 0, 0, 0, and the last is 1. This one. Okay, so you count only the on digit. 64. 64 plus 2 plus 1 is 67. This one. So this is correct. Okay, so that's all on how to add. Okay, so that's all on how to add binary numbers. Thanks for watching.